I don't have editing skills. Let's just put it that way. Okay, so come back to this. The Earth's gravitational field strength decreases as the object falls. Actually, it increases. As we move away from Earth, the gravitational field strength actually decreases. But usually for our own calculation, we take it as 10. Okay, C. Air resistance acting on the object increases as the velocity of the object increases. This is true. And this is important. Okay, we did a few parachutist questions. We always ask, why did it reach constant velocity? It's because it's falling in air. Air resistance, one of it that causes it to increase is when velocity increases. What is another factor that will increase air resistance? What's another thing that will increase air resistance? The surface area in contact with the air. So these two are factors that increases velocity. You need to know this, and you need to explicitly state it in your answer if it's about parachutists, if it's about things that change their surface area. Now, the mass of the object remains constant. This is true, but not the reason why it reaches steady velocity. This statement is true. The mass is the same, right? That's why I need you all to go and memorize what is the meaning of mass. So answer for this will be C. Okay? And any question? If not, we go to the next one. Your time starts. D is not wrong. D is correct. It's a correct statement. But it does not explain why it reaches terminal velocity. Okay? Okay, what is the answer for question 18? Answer is C. Why is A wrong? But a lot of students, they will often say at the highest point, acceleration is 0. So that's why over here, I ask you all, at maximum height, what is 0? Velocity is 0. Okay? There is still acceleration. There is still acceleration. The Earth is still pulling it down with a force of, with an acceleration of 10 meters per second squared. That's right. The time of rise from P to Q is greater than that. That is not correct, right? So this is false, right? Don't really need physics to explain. Now the ball experiences a steadily increasing upward force. When it is going up, let's say over here, can you tell me what is the force that's acting on it? What is the force acting on it? If I were to ask you to draw a free body diagram of this object at this point, what is the force acting on it? Free body diagram. There will only be weight. But the motion as it goes up is, the motion is upwards, right? If it goes up, there's a weight pulling him down. That's why he will slow down. That's why the velocity at the initial point of launch is the highest. Alright, you throw something up, you must launch it with a velocity. It must move from your hand. But as it goes up, because the weight is pulling it down, right, it's in the opposite direction of its motion. That's why he experiences a deceleration. That is why the speed when it reaches the maximum height is 0. Yes. Why is B wrong? The time of rise of P to Q is greater. So if let's say, okay, let's do B. Okay, what do you think is the initial speed? Let's say 20 20 So after 1 second, what will the speed be? If there's no air resistance, it will become 10. After 1 more second, will be 0. So it will be something like here. Correct? But after that, when it reaches the highest point, what is the speed? At the highest point, the V is 0, right? Is there still acceleration? There is, right? So what will happen to it? it will go down as because it's a velocity time graph, right? So it will still be 10 ma, correct? 10 meter per second square, right? So after one more second, what will be the speed? Will be 3, will be negative 10, and then negative 20. Because the distance traveled is the same, and it is subjected to the same amount of acceleration. Won't it take a longer time to go up? Why will it take longer time compared to what? Yes. Yes, yes. But if I were to change it by 30 meter per second, 40 meter per second, isn't it still the same thing? Because the acceleration is the same. Or you can use A equals to B minus U over T. Lor. What is our final V? Still need me to explain? Huh? Okay already, huh? So going up time is the same as coming down time. Same. So are we okay with question 18 already? Okay, then let's do question 19 now. The answer is A. Okay? When you throw an object up, you throw the object up. Does your hand follow through? Does your hand go up together with the ball? So if not, then a lot of my basketballers, when they throw the ball up, I'll see them flying upwards into the hoop. Correct? You only shoot the ball leaves your hand, and that's the amount of force that you exert to launch it. So once it's up there, what are the forces acting on it? Weight of the ball, the weight of the ball. And the weight of the ball, W equals mg, so it will be subjected to the same acceleration. Okay? It will be subjected to the same acceleration. So are we okay with this question? If okay, we go to the next one. Flow method. Okay, so for this, we need to draw a VT graph. Okay, I advocate using VT graph because VT graph always very useful. We can use gradient, we can find the distance traveled. So if I were to sketch it, initially it must have some kind of velocity. If not, it won't go up. But as it goes up, the speed actually decreases, such that in the end, it reaches zero velocity after 0.8 seconds. And in order to find the distance traveled, I need to find the area under the graph. But then I don't know what is my initial velocity. So I can use this formula. I substitute in, I get my initial speed to be 8 meters per second. That means every second, the speed decreases by 10. Right? That's why it decreases to speed of 0 within a time of 0.8 seconds. It doesn't even have 1 second. It's less than 1 second for it to reach speed of 0. So now that we know this is 8 meters per second, then I can find the area. Area is half times base times height. I will get 3.2 meters. So answer is B. Did you all get your answer for B? I use A as negative because the ball is going upwards. The ball is going upwards. The object is going upwards. And if I take upwards as positive, that means my initial velocity must be positive. But acceleration due to Earth is downwards. So therefore it must be negative. It is better because in the end you will get your velocity to be negative. Then you'll find that it a bit not following the convention. Okay? Any other questions? If not, then I introduce to you the formula method. S equals to ut plus half at square. This is the unknown. I'm supposed to find the S. This is also unknown. Okay. This is known. This is known. Alright. So this one not very useful because I have two unknowns in one formula. So how about I try, what is V? V is final velocity, right? So when it reaches the highest point, the velocity is 0. So U square, I also don't know. So I have two unknowns, you know. So I will need to combine these two, form a simultaneous. Okay? Okay. Okay, question 23. Have you all tried it? Answer is D. Okay, how about 24? A body was released from rest at a great distance from the surface of the earth if the air resistance was significant. Just now we ignore air resistance, but now we bring in air resistance. What is the average acceleration of the body during the fall? So this is earth, body was released here. So as it's falling, what are the forces acting on it? What else? They have air resistance, right? So then what will be the average acceleration? It will be A. Why? Because if you draw the free body diagram with air resistance, and air resistance always act opposite to the motion, right? If it's falling down, air resistance goes up. What happens to the F net? F net, it doesn't decelerate, Okay, so since we are on this, so F net equals to W minus AR. Compare another questions whereby there is no air resistance. Guys, please listen up. This also happens in a 2022 paper. Compare this case, there's no air resistance. The free body diagram, there's only weight acting downwards, right? And weight is W equals to mg. Because there's no resistive forces, therefore it will fall with acceleration of g. This one, are we okay? But here, because there's air resistance, so my F net is no longer just weight. There's also another force called air resistance acting outwards. Therefore, I still have F net. I still have F net. But F net 1 is less than F net of 2. Do you all get this? Which one is 1, which one is 2? Number 1 is this, the one with air resistance. Number 2 is a case whereby no air resistance. So F net 1 will be less than F net 2. Therefore, the acceleration of 1 will be less than acceleration of 2. But does it mean that the body is decelerating? The body is now accelerating at a lower rate. Is the speed still increasing? The speed is increasing at a lower rate, but it's still increasing. Because just now I heard you say it is decelerating, so no. As long as there's acceleration, and if it's in the same direction of the motion, the speed will increase. If it's accelerating at a constant rate, the speed will increase at a constant rate. If it's accelerating at an increasing rate, the speed will increase at an increasing rate. If it's accelerating at a decreasing rate, the speed will increase at a decreasing rate. That means it's no longer increasing that much, but it is still increasing. Okay? Yeah, I say so much, I draw the graph. Vt, constant rate, increasing rate, decreasing rate. Okay, and this is usually the most common mistakes that students make. Okay, when they say accelerating at decreasing rate, oh, the speed it is decelerating or the speed is decreasing. That is not true. The speed is still increasing, but at a slower rate, at a decreasing rate. Okay, so the answer for this is A. Right. Shall we do the last one very quickly? Two objects have the same size and shape, but one is lighter than the other. They are each dropped from rest. Comparing the two objects, the lighter object has. This was actually one of the questions in 2022, your paper 2. I've done up the video, so you all can go back and read up on it, watch it. So the lighter object has the same initial acceleration. Why initial? Initially, when it is dropped, same size, same shape, right? But this one maybe 1 kg. This one is 100 kg. Same size, same shape, ah. So initially, when they drop, what is the amount of air resistance? Initially, the air resistance is 0. Why is it initially at 0? Although there's air. Because initially, speed is 0. And just now we talked about air resistance increases as speed increases. Not really, but we don't need to quantify it. We can just say, oh, as speed increases, air resistance increases. But of course, there's a formula, but that is beyond our level and beyond my level, I admit. So as it falls, the air resistance increases. The air resistance increases. Let's draw the free body diagram. Am I drawing the free body diagram correctly? Am I drawing the free body diagram correctly? Why not? Weight is not the same. Therefore, in order to draw it correctly, my weight for this guy must be 100 times longer. But then air resistance kicks in. Air resistance kicks in. So initially, maybe about the same. Which one will still experience a resultant force? Both will experience. But which one will experience a larger resultant force? So you see the importance of free body diagram. So this guy, the air resistance increases until it is equal to the weight. So this guy experiences no F net. But if I give him this amount of air resistance, will there still be F net? There is, right? Because my weight is so much. This amount of air resistance is not enough to balance my weight. So there will still be F net, so it will still be accelerating downwards. Right? So if it accelerates, his terminal velocity is going to be so much higher than the one that is of a lesser mass. So answer is C. The lighter object will have the same initial acceleration, but it will have a lower terminal velocity. Okay?